Hello friends, I'm back with my next video. In this video, we are going to discuss about priority scheduling algorithm. Now there are two types of priority scheduling algorithms. One is preemptive, other is non-preemptive. In this video, we'll be discussing only about non-preemptive priority scheduling algorithm. In the next video, we'll be discussing about preemptive priority scheduling algorithm. Now, as the name suggests, priority scheduling, the processes are decided based on their priority. That is, the process with the highest priority is considered for execution. Now whenever a question comes in the paper regarding priority scheduling algorithm, the first thing that you should be noticing is whether the question says that the largest number is the highest priority or the smallest number is the highest priority. And in case it's not mentioned in the question which number is the highest priority, you have to make an assumption and make it clear to the examiner what are you assuming. That is, whether you are assuming the largest number or the smallest number as the highest priority. So now in this example, what I've written here, it is given that largest number is the highest priority. That means here number 12, that is process 6, is having the highest priority, and next is 10 and so on. So here number 2, that is priority 2, is the least prioritized process. Okay, so now we'll start with the solution. So as you all know, the first step is drawing the Gantt chart. So in this before drawing this, you should also consider arrival time here. Though why is that arrival time required here? Because although the process is having the highest priority, if the process is not arrived, how will CPU schedule it? So you have to first check if the process has arrived, and if the process has arrived, then only you can give it for the scheduling. So starting with arrival time 0, so when I consider arrival time 0, there is only one process which is present here, that is P1, and there is no other process. And since it's non-preemptive, I have to consider the process until it finishes its job. That means I'll just write here process P1, and the burst time for process P1 is 4, so I'll just mention it here that it's 4. Okay, so now you can just mark this so that we don't get confused with what is the okay. So now at time 4, we will see which all processes are available. So at time 4, that is 1 2 3 4, so till here, that is P2 P3 P4, all these 4 processes are available to us. So now we need to compare its priorities. So which process is having the highest priority here? The process P4 is having the highest priority because it is having the largest number. So I'll just put P4 here. What is the burst time for P4? The burst time for P4 is 5, so it is 4 plus 5, it becomes 9. Right, so I'll just mark this with red. Okay, so the next process that we have to first check, right? So till time 9, which all processes have arrived. So now if you can see, the last process that has arrived is at time slot 6. That means all the processes have arrived. So now we need to only check their priorities before scheduling. So now we will just ignore the arrival time column because all of them have arrived already. So the next priority process here is your 12, right? So this is having the highest priority, so it is P6. So I'll just write here P6. What is the burst time? That is 4, so that means here it will be 13. Right, so the next one that we have here is, I'll just mark this one also red. Okay, the next process that we have here is process P7 because it is having the next highest priority. So I'll just mention P7, and its burst time is 6, so 13 plus 6 is 19. Okay, so the next process that we have with us is, I think, 8, so it's process P5 that should be considered. So P5's burst time is just 1, so this will be just 20 here. The next process is, I think we don't have to mark anymore, so directly we can know that it's P3, and the next process is P2. Okay, so I'll just write the burst time of P3, that's 3, so it will be 23. Okay, and the last one is 2, so it should be 5, right? 25. Okay, so that's with your Gantt chart. So now we all know how to solve the table. The completion time is this time what we have here in the Gantt chart. Turnaround time is your completion time minus the arrival time, and waiting time is your turnaround time minus the burst time. So I'll just write the completion time for process P1, that's 4, because we have 4 here. For P2 it's 25, for P3 it's 23, for P4 it's here, that's 9, and P5 it's 20, right? So P6 is 13, P7 it's 19. So that's all is your completion time. Next is your turnaround time, so I just do this minus this, that's your 4. So next you have 24, next you have 21, next is 6, next is 16, 20 minus 4, 13 minus 5 is 8, and lastly we have again 13, so 19 minus 6. Next is your waiting time, that is this column minus this column, so 4 minus 4 is 0, 24 minus 2 it's 22, next 21 minus 3 is 18, next is 1, 15, 4 and 7. Alright, so now we have all the values, so we are going to calculate the average turnaround time. So average turnaround time in this case would be 4 plus 24 plus 21 plus 6 plus 16 plus 8 plus 13, all of them divided by its 7, summation of all divided by 7, and answer is 13.14. and your average waiting time is equal to again the same, that is 0 plus 22 plus 18 plus 1 plus 15 plus 4 plus 7, entire thing divided by 7, so that equals 9.57, right? So that's all, as simple as that. So you have to just consider only your priorities in this particular algorithm, and do not forget it is non-preemptive that we have considered here. Let's see one more problem here. So now in this problem, if you can see, there is no arrival time mentioned here. So we have already seen in our previous videos also, if arrival time is not mentioned, we have to assume it to be 0. That means all the processes have arrived at the same time. So I'll just start the Gantt chart with 0 here. That's your Gantt chart. Okay, so we have to just consider the priorities because arrival time is not mentioned. So here again the largest number is supposed to be the highest priority, so largest number is 5, so I'll just put P2, and for P2 the burst time is 10, so here it will be 10. Next one is your P1, the burst time for P1 is 12, so this will be 10 plus 12, it will be 22. Next one is your P5, because the priority is 3 here, that's 3, so it becomes, because its burst time is 3, it becomes 25, right? Next one is your P3, and that is 5 again, so this becomes 30. And lastly we have with us is P4. So P4 here is burst time is 4, so this becomes 34. Simple enough. Only thing, the difference between this problem and previous is the arrival time is definitely not given. Sometimes students get confused, since arrival time is not given, what is to be done. So it's actually good that we are considering all kind of problems. Okay, so I'll just write the completion time here. So P1's completion time is 22 because it's here. P2's completion time is 10. Okay, P3's completion time is 30. Okay, then P4's completion time is 34. Okay, and lastly P5's completion time is 25. Right, so next is turnaround time is this minus your arrival time. Since arrival time is not given, it's 0, that's what we know, and that's why all these values will be same for the turnaround time. And waiting time will be turnaround time minus the burst time, so 22 minus 12 will be 10. Next is 10 minus 10 is 0, 30 minus 5 is 25, 34 minus 4 is 30, and 25 minus 3 is 22. So average turnaround time, again add all of this and divide it by 5 because there are 5 processes. Again, for average waiting time, add all of this, divide by 5. So I'll just give the answers, please try it by yourself. It's 24.2 and this is 17.4. Alright, so we'll just see one more problem. In this problem, what is given is lower number is given has the higher priority. So that here the lower number is 1, that means 1 is having the highest priority and 5 is having the lowest priority because it's been given that way. Okay, so other procedure is entirely same, only thing considering priority is also an important factor here because it is priority based scheduling algorithm. So you have to read the question very clearly what is given. Okay, so I'll start with the Gantt chart here. I'll just show you how to draw the Gantt chart and rest all will be your homework. So Gantt chart is starting with 0 again because again here arrival time is not given, so we are assuming that all of these processes have arrived at time 0. So the highest priority is with this, so it is P2. So P2 process, burst time for P2 is 1, so here it will be just 1. Okay, next is your P5. So for P5 the burst time is 5, so this becomes 6. Next is 3. Okay, that's your P1. The burst time is 10, so 6 plus 10 is 16. Next is your 4 is your P3. So P3 burst time is 2, so it is 16 plus 2 is 18. And lastly we have P4. The burst time is 1, so it's become 19. Okay, so that's all. And now the completion time, turnaround time and waiting time, everyone knows how to calculate, so I'll just write your completion time of P1 it's 16, P2 it's 1, P3 it's 18, P4 that's here, P4 19, and P5 that's here, that's 6. Alright, so turnaround time will be your completion time minus arrival time. So again arrival time is not given, so I'll just copy these things, the same values will be there in this turnaround time. And lastly we have waiting time, so that is turnaround time minus the burst time, so here it comes 6. Next is 0, 18 minus 2 is 16, 19 minus 1 is 18, and 6 minus 5 is 1. So average turnaround time is addition of all this divided by 5 because we have 5 processes, and waiting time, average waiting time is addition of all this divided by 5. So I'll just give you the values, please try it by yourself. I'll just give you on 8.2 Every turnaround time you have to calculate by yourself and to check it. Thank you so much for watching this video. Do subscribe my channel. Thank you.